Okay. Hey, everybody. Thanks so much for coming to my talk. It's a really good turnout here. I'm Mohammed. I'm a principal architect for Armis. And today I'm going to be talking about 4 ways IoT devices are creating privacy implications for organizations. Now, just to set the stage a little bit, in my career I've been fortunate enough to work for a healthcare institution, one of the large ones in Canada, and I've been involved in pretty heavily in a number of different privacy discussions, some privacy breaches, but I've also been involved in doing risk assessments for a number of different critical infrastructure areas as well, such as utilities, water plants, as well as dealing with financial institutions and so on. So there's quite a few different angles of privacy that I'll be touching upon. And the reason I chose this specific topic is I think there's quite a bit of coverage when it comes to IoT devices around the security implications, right? And I like to think of privacy as almost like a little annoying cousin that always tends to get forgotten up until they get into trouble at a family barbecue, that something crashes, there's a lot of noise all of a sudden that happens, and now they need a lot of attention all of a sudden because they're crying. Now, one thing is I was given the option of wearing a wireless mic, so you're gonna see me pacing quite a bit. In my mind, I feel like Steve Jobs. I'm sure to you guys I might look like Hassan Minhaj instead. So with that, let's give an overview on what I plan to cover. And quick thing, by a show of hands, how many folks here are in information security? So more on the cybersecurity side of the house, okay. And then can we contrast that with who is in the privacy realm of their organization? Okay, a few hands there, perfect. So just to level set, I'm gonna talk a little bit about the IoT challenges from a security perspective first, because I think security and privacy really go hand in hand, right? You gotta have the security controls in order to help assure from a privacy perspective. But then I'll really want to talk about how IoT devices are really implicating business risk. I love highlighting and kind of elevating the conversation from technical vulnerabilities over to the business risk that gets presented, especially considering what an integral part IoT devices play today. Then we'll jump right into privacy implications. So the 4 examples that I'm going to cover today are going to be related to the unencrypted data generated or processed by IoT devices, a credential-based view, because we all know that access to data is one of the prime ways to either secure it or leads to breaches. We'll talk about how IoT devices have their default or misconfigurations that also they get shipped with and don't get changed or secured. And then we'll have a little bit look ahead in terms of innovation that's coming down the pipe. Very, very interesting, very different, but can also lead to a number of different privacy challenges. And then the second part here of the privacy discussion is, I want this audience to have a takeaway that, when you go back after RSA, well, let's say Friday, or you go to your organization on Monday, you have tangible things that you guys can do to start addressing some of these issues that I'm gonna talk about. So with that, let's jump into some high-level IoT challenges. Now, the one thing here is that the adoption of IoT technologies is everywhere, right? So if I think back to it a little bit, 2010 or so when the iPhone came out, right? Little did we know that this device is gonna really change the way we operate as a business, right? So everybody was lining up to buy it because, hey, it's the newest cool thing, I can install Angry Birds on it and all that fun stuff. But really, it's fundamentally changed a lot of what we do. And what's tricky about IoT is also how fast the adoption happened. So up until, I'm gonna say, 2017, I love using WannaCry, the ransomware attack globally, as kind of the litmus test, or kind of that line of delineation. When that happened, you had a lot of board members asking, are we secure? So security really started becoming mainstream for a lot of organizations. Now, initially, the focus was a lot on enterprise devices, servers, laptops, desktops of the world, and so on. But while all that focus was on enterprise devices, the IoT kind of era was ushered in. You had physical security departments replacing their IP cameras. You had smart devices that were being installed everywhere, HVAC systems all throughout your buildings and your building management systems and so on. So what ended up happening then is once we started seeing that enterprise devices are secure and attackers started targeting IoT devices, all of a sudden the focus shifted a bit. And especially nowadays when you're seeing a lot of attacks on critical infrastructure. So what's happening is all of a sudden there's a big shift, but those IoT devices are already embedded into your business operations. They're already being embedded in all your different smart buildings. And just to cover a few examples here, right? You can go to an airport and there'll be facial recognition technology, there'll be registration kiosks, there'll be obviously a number of different IP cameras, different X-ray machines, and so on. From a medical perspective, right? All these different smart IoMT devices now. In fact, there's IO of everything, right? Whether it's IoT, IoMT, OT, IOV, smart vehicles, smart cities, and so on. Even when it comes to payment systems. So the privacy doesn't only stop at health, patient health information, but it'll also happen when payment card information, customer data, right? Where do they live? Where are we shipping this information to? Information about birthdays, and so on. Then, of course, your smart home, right? How many of us are purchasing a whole number of different devices, plugging them in? We have a huge security audience here, so of course, I'm assuming you guys are taking some of the security best practices and changing some configurations around, but also, what about the general population, where they're installing Amazon Echoes and their Nest devices and what have you? So all this to say that IoT has proliferated all over the world throughout all the different industries and all the different types of organizations that exist. Now, a quick recap in terms of what are some of the security challenges around these devices. Well, the first one is the increasing blind spot, right? So security teams have been really good at securing enterprise devices. I purchase a desktop, I purchase a laptop, I spin up a server, and it's all coming through my department. So I know I have these lists of 10 requirements in order to secure these devices. What does that mean? Well, I'm going to install a patching agent on it, I'm going to install asset inventory on it, I'm going to install antivirus on it, and only when it meets these requirements, do a vulnerability scan, will it be allowed to be on my production network. Now with IoT devices, what happens is it's decentralized purchasing that's also creating problems. So what do I mean by this? Well, you have all these different departments that are now going out and purchasing all these different devices. And what are they trying to do? They're trying to innovate the way they deliver services, right? So I'm going to buy the latest and greatest technology. I'm going to use this iPhone as my payment system instead, and I'm connecting it to the network, and the security teams have no idea, right? So that increasing blind spot, it's NIST 101, Cybersecurity Framework 101. How do you secure what you don't even know is on the network? The second part is, let's say you do realize the physical security team does engage you to say, we purchased all these devices. Now, traditional security controls don't necessarily apply on these devices. So what do I mean by this? Can you install an agent on a IP camera running Linux, right? Maybe. Chances are no, but let's add 5% to say, yeah, sure, we have an agent that supports Linux. What about the more specialized operating systems? What about on a ATM machine or a payment card terminal, right? Are we able to install antivirus on it? Are we able to secure it with our traditional security technologies and agents? Combine that with the fact that manufacturers are always looking to cut costs, right? So instead of me shipping this massive payment system terminal or what have you, you can just install something on an iPhone. Here's an adapter, install it on an iPhone, on an iPad. So I don't need to ship you this massive registration kiosk. You can just use an iPad. So what we're seeing with that is the fact that there's now devices that are being used, more generic devices that are being used for business context. And then there's, of course, change adverse. IoT devices aren't necessarily, they're not that friendly to being updated. A lot of times when you're looking at a lot of these specialized environments, OT, IoMT devices, it's more along the lines of you need to purchase in order to upgrade. You can't necessarily do it from a software perspective. Vulnerabilities, they're always increasing, right? It seems like every other week, every other day, we're coming across vulnerabilities that are always critical in nature. So we're getting faster at identifying vulnerabilities. That's why I like to call it the velocity of vulnerabilities. It's just coming out at an increasingly high pace, and security teams are tasked with keeping up with those. And then the last part here being remote access, right? A lot of us, I'm sure, have heard of and deal with third party, right? Risk management. So when I buy these devices, vendors say, you know what? Because they're mission critical, we need to be able to service them immediately if there's any type of interruption, downtime, et cetera. We're cutting out the time needed to engage us. We can just automatically remote into your environment. Well, attackers know this. So a lot of times what's happening now is you're actually seeing the vendors get compromised, and then from there they're able to jump over into their customers and compromise the network that way. So all of this to say that this has resulted in an expanded attack surface that's much more difficult for security teams to control for. But it's also security teams are now tasked with securing unknown devices that they don't necessarily have as much experience dealing with, and they have unknown workflows and a lot of times unknown impact. So myself as a security, you know what? I'm a security professional. I know what I know about the security domain, but all of a sudden, if I'm dropping into, let's say, a nuclear plant environment, right? Will I know the inner workings of all the different intricate components that are there? Will I know all the different smart components that are interacting to provide the power? I will need the help of a plant operations engineer, right? So I don't know how these devices interact. I don't know how they're composed. I don't know what data they're generating, but yet I'm responsible for securing them. And that leads to additional risk simply because I don't know about these devices. That can be safety risk, right? Think of a water treatment plant. If there's any type of compromise that happens there, well, what about the consumers of the water, right? What about the privacy risks that we're going to talk about, but also things like operational risk that results from these types of devices? Now, let's talk about the privacy implications. And this is where we're going to shift the focus a little bit from the devices to also the data that those devices are processing and generating. Now, I know there's a lot of security folks in the room, so just to level set with everyone, you'll hear me mention a few different acronyms and talk about a few different things. So quickly level set. When I mention PII, PHI, it's personally identifiable information, protected health information, and this can include name, address, phone numbers, date of births, and in fact, even IP addresses, right? And one common theme you'll hear me harp on over and over is it's not only the transmission of all this data together, but it can also be how you reconstruct this data. So if you have multiple different devices, each transmitting a fragment of data, but all of a sudden it's getting reconstructed in a business intelligence platform, right? That's also potential privacy breach. Then the other part, actually I jumped ahead there. And then you'll hear privacy risk versus privacy breach. My focus is going to be more so along the lines of privacy risk, but I will insert some anecdotes around privacy breaches that have occurred with IoT devices. So let's talk about the first scenario here. And this one's pretty straightforward, where we're looking at unencrypted data, right? So IoT devices, keep in mind that they really were made for innovating and streamlining some type of service. They weren't built with security in mind. They were just, hey, how do we do things better and how do we do things faster? And to that effect, depending on what type of IoT device you're looking at, it can be power meters at your house, it can be payment systems, it can be medical devices, OT. There's a lot of data that they're storing, processing, and transmitting. And this is related to usage, how you're utilizing certain types of devices, sensory data, so them detecting, I see somebody that's passing by here, or somebody's pulling into the parking lot, right? All those different parking sensors as well. There's also how are we seeing changes in the actual information? And what's really, really interesting is I was reading up on smart power meters, and based on the usage, you can obviously tell if somebody's home or not. But also, based on the patterns of the smart meter, you can even deduce what channel they're watching on TV, right? So this is probably, I'm gonna put money down that people probably didn't account for this when they came out with smart meters. The fact that it can be used to deduce what channel you're watching on TV. And then of course there's diagnostic information, and obviously from the medical side of the house, but also if that IoT device crashes, what was that device doing? What's the information in those diagnostic reports? I've seen vendors configure devices to automatically send diagnostic information about medical devices, and it's going out to the internet. It's going out to the cloud. Are security teams, are privacy teams aware of how frequently, of what's included in those diagnostic reports? Are they aware of where those reports are being sent to, right? There's a big difference if the device is in the US and it stays in the US versus it's going across the world, it's going to Japan, it's going to Russia, it's going to South Asia, right? A lot of different privacy implications around that. And the other part is a lot of this can be unencrypted. So recall that I mentioned that IoT devices inherently won't necessarily have as many security capabilities as their enterprise counterparts, right? So that encryption at rest, or that encryption in transit, right? Some of the more fundamental security capabilities and controls. Now, if I'm not properly encrypting that, information from payment systems. Now we have PCI DSS, which is, really set the bar, and it's much better than having no standard at all. But if we're looking at what about those databases that have all the customer information, or the HR databases that are now in cloud platforms? Do we understand what security controls are in place there? A lot of times when HR may have procured it as a SaaS platform, we're good to go, but there was no real security done, and there's a lot of security that can be applied in the cloud, right? Something that's really hot right now is API security, API keys that a lot of IoT devices rely on to transmit information, but how many of us actually get into a risk assessment of those, even those API keys? The other part is also unencrypted video and data. So if I take a step back, medical devices have a lot of innately unencrypted patient health information going across the wire, and I'll talk about that in the next slide. But the other part is also even IP cameras, right? So they actually transmit a lot of the information unencrypted, especially the earlier ones. And that in and of itself can obviously lead to a lot of different details. And what's interesting about that even is the placement of these IP cameras. Are they in an area that can see what's on the actual monitor? These, the resolutions are getting much, much higher. Are they pointed in a hospital where they have an electronic whiteboard that has patient details on it? Is the hospital actually writing the full MRN number, the full patient number? That in and of itself can also lead to privacy risks there. Now, I wanted to showcase, for each of the different scenarios that I'm going to explore, actual real-life examples that we have detected and uncovered. And this is going to be from a plethora of different industries and verticals. So the first one being unencrypted PHI example from a hospital. Now, this is a screenshot of the Armis platform. I'm not here to market the actual platform in and of itself, but I did want to showcase some of the things that we have found when we deployed in environments. So the first thing, do I have laser print? Perfect. The first thing here, as I was mentioning, kind of that legacy approach, the legacy operating system that's on a medical device. Now, this device probably cost $50,000 at least, right? Now, multiply that by, let's say 10 devices. Well, let's start simple, right? And I've lived this, where I'm a security team, we're eliminating all Windows XP devices in our environment. Hey, pharmacy department, you have these pharmacy drug cabinets, they're all running Windows XP. We need you to update them. We need you to upgrade them, okay? They talk to the vendor says, no, you can't upgrade them. You need to buy brand new devices. They cost $100,000 a pop. They come back to us and say, well, listen, we have 30 of these. You're telling me that I need to replace these. From an operations perspective, they work fine. So 100,000 times 30, if my math is correct, that's $3 million. So security team, are you willing to give us $3 million to purchase these new devices, right? The conversation very, very quickly changes at that point. Now, looking at the actual behaviors of the device here, this is where we're seeing the unencrypted PHI going from this device, not only internally, which can be expected in a healthcare environment, but there's two things that I want to talk about. Let's talk about the bottom part here. It's transmitting that unencrypted PHI internally, but what exacerbates this issue is the fact that the actual network topology, right? So imagine there's a completely flat network. Somebody can come in and plug in whatever they want. They're able to get their hands on this data, right? And the fact that these legacy protocols, unencrypted, you can literally just sniff this off the network. I have your patient name, patient number, patient date of birth, the physician, their address, test results, medical images, and so on. Then the second part is the fact that there's also this data going out to the internet, right? These are the types of things that, while IOMT has been around for quite some time, let's say, over 10 years now, the fact that a lot of this has gone unchecked. So now that there's a huge focus on IoT security and what have you, it's also the behaviors beyond the vulnerabilities that exist on these devices, beyond the technical end-of-life systems and operating systems. It's also what is the device transmitting. Okay. Now the second part here, second scenario, is unencrypted credentials. And I like to call this one hop away from a privacy breach, right? The fact that there's credentials that are being transmitted across the wire, similar to how we can sniff out the patient data in the previous example. What's stopping me from grabbing credentials off the wire and also logging into whatever, whether it's a cloud portal, whether it's a HR database, whether it's an application, anything along those lines. Depends on the access the user account have. And IoT devices leverage the user accounts in a number of different ways. Now, the first one being they're largely unencrypted. A lot of times they're documented. So if you wanted to just Google, what's the default password for this camera or this cloud console, chances are Google will actually tell you what credentials are being used, right? And chances are they haven't been changed. So a lot of times they'll be hard-coded, okay, that you cannot change regardless, but also other times, because it's decentralized purchasing, imagine the physical security department, if they have, and not to harp on them, but if they have IP cameras that are talking out to the cloud console, chances are they probably haven't gone through the appropriate security measures unless there's some type of a walkthrough that forces you to change your password on first logon, which might be a newer approach. 10, 15 years ago, I don't think that was the case. You can just Google, this is the IP camera I have, what does it talk to and what's the credential that it uses? And then you'll be able to access and see what the device is monitoring. And the thing here is that it's not only on individual devices on a per industry basis. This can be shared across. So the IP cameras in general, right? Regardless of infrastructure, it's not a randomly generated user account or password or anything along those lines. You can literally get access to hundreds of thousands of IP cameras, and that's what attackers are starting to do. It's not necessarily the IP cameras on an individual device level, but they're starting to go after the actual cloud consoles. And I believe this was last October or so, where we had 150,000, give or take, IP cameras that were accessed in an unauthorized manner because the attackers were able to harvest admin credentials of the actual cloud consoles. And this gave access to manufacturing plants, this gave access to hospitals, this gave access to government facilities. So really it's a wide plethora that all kind of get connected into one single cloud platform. And keep in mind that the IoT devices can also talk to existing infrastructure, right? So when we look at an architecture diagram, again, that traditional way is client server. I have the server, it's talking to these 50 different enterprise devices. They talk back to the server, they get some type of application access. Kind of the next gen architecture that we're missing is all of the different IoT cameras that also plug into that same architecture. So it's not only that your enterprise devices talk to that application, but now you have a whole bunch of different IoT devices that also report into it, right? Now all those different credentials that are going across the wire, they can access databases, they can access servers, they can access applications directly and log in. And some of them might use encrypted credentials. The reason I say encrypted is what good is 64-bit encryption in today's world, right? The way I kind of equate that is you have a house that has an empty doorway, completely wide open to the street. 64-bit encryption is like adding an unlocked door to the front of it. You literally just have to walk up, open the door, and you're in. And historically, the focus hasn't been on the innovation, it's been more on the availability, and unencrypted credentials, as I was mentioning earlier, aren't the only threats, because take into account things like the cloud platforms. Now, if I were to show you an example on what we found in live environments as well, this is actually one single environment, okay? And you can see, and kind of working my way up, they can be something as simple as, you know what? They, by default, use unencrypted or insecure protocols. So something as simple as, instead of using SSH, they're all using Telnet, right? So the entire networking infrastructure, it's going across the wire unencrypted admin network. And mind you, some of this is anonymized. These are all anonymized, so you can look them up, but you won't find anything. But also root. So to access these devices, to log in, to reconfigure them, these are all going across the wire in clear text. They're all documented. You can Google them. But then as we move up, it's not only the network infrastructure, but now we start getting into things like FTP of data. So whether it's patient data, whether it's customers that have visited us today, or customers that have, whether it's payment systems and payment details and things of that nature, we're exporting that information. And that can be to a business intelligence platform, that can be to whatever destination, but the fact of the matter is that we're leveraging FTP, because that is what the IoT devices support. They don't support the more secure FTP protocol, as an example. Then as we start moving up, this is where it gets, where I love talking about this, is service accounts. So far I've been talking a lot about IoT devices, accessing, logging in, and things of that nature, but also service accounts to newly implemented platforms. We've seen when hospitals have implemented these massive transformational HIS platforms, we're still detecting unencrypted credentials going across the wire. So the organizations have effectively spent $50 million, but unencrypted credentials giving access to the entire database are still prevalent across their network. And then when you go a bit further up, this is where even user accounts. So as they're logging in, whether it's from the actual, and keep in mind, IoT devices aren't just IP cameras. They can be actual massive devices that have a Windows front end, right? So it's an embedded computer into a massive device, an OT device as an example, and you might be logging in. You launch an application, you log on to the device, but again, because the security teams didn't have the ability to make changes on these devices, because the vendor said, these devices are configured as is. So as you purchase them, when vulnerabilities come out, you cannot patch them. You cannot disable services. You cannot change the way that these devices behave. So when it comes to that, I'm logging into the application because this OT device needs to make some changes to the environment. And then I'm logging in as myself, but it's innately insecure. And we cannot reconfigure these devices. Now, the other part becomes the default and misconfigurations. I've been talking about this throughout the presentation here, but imagine where it's building management systems and HVAC units. If it's providing the service that I needed it to, as long as it's working, as long as it's working, and the connection to the internet, the connection to the network, the connection to anything it needs to actually operate, as long as that's up and running, why do I need to contact the IT team? Why do I need to contact the security team? It's a very plug-and-play approach. I purchased a brand new device, I plugged it into the network, I connected it to the wireless because I know the wireless password, and my IoT device is working. Now, the trick is, those earlier points that I mentioned, well, it's pre-installed and it also has remote access always on. Sometimes what will happen is whether it's a TeamViewer, whether it's a LogMeIn or anything along those lines, they're coming pre-installed on these devices. Raspberry Pis, classic example, small little credit card sized devices. They're getting deployed for monitoring your environment throughout. They're getting deployed to data centers. And what we're finding is they're deployed with TeamViewer pre-installed. So you get massive spikes in TeamViewer activity. Hey, security team, were you guys aware of this? No. What is this device being used for? Well, it's being used for HVAC systems, for monitoring that. Okay, well, somebody has unauthorized or unvetted remote access directly into your environment. And then, of course, the cloud platform access that comes, again, without multi-factor authentication configured, without necessarily the API keys or credentials having been hardened, without configuring where this data, if it should be stored, if so, where should it be stored, and so on. And the interesting thing is, how many folks here are also involved in reviewing, let's say, contracts from both a privacy and security perspective? Oh, I love it. Got a few hands coming up. Perfect. I remember when I reviewed, this must have been a 25-page contract for a regional collaboration of different organizations. We were very cloud adverse at the time, and there was literally just one sentence in there that alluded to the fact that cloud components were being used. And when that was brought up, and it was asked multiple times, how is this happening? What's the architecture of this, and so on. And everybody was ready to sign off, but it's like, what does this one line mean? It sounds like there's a cloud platform involved. And then after digging deeper, it turns out there was. Now, if you're in kind of collaboration mode, if you're talking about different shared responsibilities and sharing of sensitive data and confidential data, it's one thing if you're hosting the data and we have our agreements. But now that there's a cloud provider involved, that completely changes the tone of the conversation. That completely changes who's coming to the table and why. So it's really, really important, and you'll see this when I get to my recommendations of having security teams and privacy teams involved in reviewing contracts. I know security teams, maybe they might be involved in SLAs for incident responses and breaches and things of that nature, but really it goes much further than that. So what contributes to this type of blind spot I was mentioning? Your decentralized purchasing is a big one. Your plug-and-play approaches of, hey, just plug it in, everything works, it calls out to whatever it needs to, and so on. Now, this is the example here where we found an IP camera that was actually calling out to external IPs out on the internet, and over real-time streaming protocol, so this was actually streaming out over 20 gigs of data, right? So this is an IP camera that was actually actively streaming out directly to the cloud. Nobody had any idea about it, not even the physical security teams. Now, in terms of innovation, and I love this one, and try to be clever here. I changed the actual layout of the slide, try to be, because innovation is very, very different. You got cutting edge, you got adoption of IoT technologies. A lot of times they're proof of concepts that just, hang around and said, yeah, we've implemented it. Research departments often get grants, they get funding, right, to do these types of adoptions and innovations. And there's two things here. One is, because they're not working as closely with the security teams, they're kind of off doing their own thing. The flip side is, because they're bringing in $10, $15, $25 million to the organization, security teams can't really say no to that, right? Even you might find out through a change management process that, hey, we're implementing this tomorrow. It's the go live. Whoa, who did the security review on this? What data is being transmitted? Where's that data going? And so on. And I've lived that, where when I was talking to the research department, it was, hey, we have a 5-10 day lead time to spin up VMs and things like that. Oh, don't worry about it, we'll spin up our own. How? Oh, we just log on to Microsoft.com and we can spin up as many VMs as we want. And we're like, oh, okay, so you're using Azure for business intelligence. And what did I mention earlier? It's not only about anonymized data, but it's also about reconstructing that data. So how do I know that that platform isn't taking all these bits of information and kind of reassembling it, and all of a sudden I have personal information out in the cloud? So there's less security and privacy involvement happening there. And when there's new devices, kind of unsure how they actually operate, what platforms are they using, how are these platforms secured, and just think back to biometric authentication. When there was eye scans happening, there was fingerprinting, monitoring of veins and things of that nature, and what did we find out after a bit? That you can actually tell if somebody's pregnant through the use of biometric authentication. So they have to change up how they actually implemented and what they actually used. And the example for innovation is looking at smart cities. So this is very, very interesting. When it comes to smart cities, right? Obviously, we've got tons of IP cameras all around the city. We have things that are monitoring traffic. We're monitoring, whether it's weather, how congested places are, who's going to the mall at what time, where in Disneyland you're walking, and where you are at that point in time. But also, how far you as an individual, as you're coming onto a bus, facial recognition technology, or the fact that you're swiping your card is associated to your identity, where you get on, where you get off, kind of tracking your movements and understanding your usage, as I was mentioning earlier. Now, what's interesting is I was reading, there's an Asian country, I can't remember if it was China or Singapore, apologies, that escapes me, but the fact that they're looking at, they have implemented sensors throughout the city, and it's a POC stage right now, but it's listening for gunshots. So if there's something that sounds like a gun has gone off, it automatically triggers a first responder to be dispatched, right? So it sounded like a gunshot, it's happened here, and now there's police on the way. But think about that. As I was mentioning, always on. That means these devices are always listening. So what type of data is being collected? What's happening with those recordings? Is it being filtered out? Where is it going? And then there's always the ethical and kind of legal aspect of it of if somebody says something, would they end up incriminating themselves if they were talking about X, Y, and Z, if they were planning something, right? So a lot of different implications start getting unfolded here. Then there's the detection of heart rate. You can, that they're also implementing in certain hospitals where I can actually detect if somebody's about to have a cardiac arrest, and again, deploying first responders. In fact, the last part that I'll bring up before I go into the recommendations here are the social credit system, where one government, I believe it was China, they're saying that we want to build a social credit system where we're going to publish this online to say, hey, Mo, you were caught stealing, so your social and public credit and your reputation has gone down by 10 points. So anybody who's dealing with you know what kind of person they're actually dealing with by making all this information available publicly. Now, recommendations and guidance. So in the next week, if we're looking at IoT devices, as I was mentioning, the first thing here is inventory, right? There is sources that exist in your organization today that should have a list of different types of IoT devices. We're just not tapping into them. Think about it. If you're in retail, somebody should be tracking your payment systems, given that PCI DSS compliance. If you're in healthcare, your biomedical team should be having and tracking an inventory because they need to maintain these devices. If I'm looking at OT operational plants or even facilities management, they usually are tracking their own assets as well. Now, understand who owns these devices. And from each of these departments, get that inventory list, and there's a number of different, there's a number of different NIST publications that a lot of times, we talk about 853, we talk about the cybersecurity framework, and we don't really go beyond that. But there's a number of different special publications, whether you're in federal or public sector, whether you're in healthcare, the HIPAA security rule, or if you're just managing IoT security and privacy risks in general. And what's great about this is the fact that they specifically call out the different types of IoT devices and the different types of data that they would generally process. So it's calling out, let's say medical devices, IoMT devices, devices with PHI, devices with X, Y, and Z types of data. These are the different types of assessments and security controls you should look at. So I really highly recommend, after you get the list of IoT devices and who owns them, it's a matter of let's go through and see what NIST recommends as a next step to secure those devices. So that's going to be immediately, right? That should be simple. Sending out an email to a few different departments, getting that information back from them. Well, now that I have all of that, it's a matter of prioritization. So how can I prioritize here? Well, there's a number of different angles that you can take. The first one being, it can be by device type and also by number. So it's that quality versus quantity type of approach. So what's the most vulnerable type of IoT device, right? A quick Google search will probably tell you that IP cameras are probably the most targeted and most compromised type of IoT device. That might be a low-hanging fruit because you can also take a multi-pronged approach there, securing the cloud platform. In the meantime that you consult with the vendors, are there any firmware updates that are available? What are the most critical types of assets? What's the ones that are touching patient or employee or customer data first, right? There's nothing wrong with doing a double take on how have we implemented those payment systems? How have we implemented the HR database? Are there service accounts that are orphaned? Have people left the organization and their accounts are still active and have access to this data? But also, what's the highest in numbers as well? And which ones have the most critical vulnerabilities? Which ones are actively being exploited today? Which ones are actively being attacked today? These are some of the different ways. Now, of course, it depends on your organization's approach and risk appetite to help prioritize. But now that you've selected those top priority, and don't try and boil the ocean, right? This is not going to happen overnight. This is going to take a bit. This is going to take a few months to start addressing all of them. But now that you have that list, now you can prioritize. And once you've prioritized the first group of assets, understand how are they behaving? What's the data flow? What's the architecture? What are they talking to? And once you have that, then it's a matter of understanding what security controls we can implement on the first one. So a very low-hanging fruit, credentials, multi-factor authentication, see which ones you can flip on the secure protocol. So going from that FTP to that secure FTP. Those are some very simple ways. And then, of course, you get down to the segmentation of these devices. That's a bit of a more complex project, but the seeds of a successful segmentation project are going to be related to what do I have, what is it doing, and what does it need to access. That's exactly what we're starting to embark on in the next 3 months. Now, finally, my final takeaways here for the next 6 months is embedding privacy, keep pressing the wrong button, is embedding privacy and security functions as part of procurement process, steering committees, and the project management office. It can be as simple as a check mark in the actual, let's say, procurement sheet that says, have you consulted the privacy and security team? And there should be 2 individual requirements here. Privacy teams can do their own assessment, privacy risk assessments, and security teams can obviously do their own. If you look back at COVID and all this rapid digital transformation, right? How much of that actually went through an appropriate security assessment or a privacy impact assessment or a threat risk assessment? Probably very little, because it was just a matter of, again, the service, the availability, and the innovation. Then there needs to be awareness training so that when other folks are going out and purchasing all these different devices, they know what to look out for. They know what questions. They know the fact to actually engage the privacy and security teams and evaluate technologies that automatically understand when there's additional devices being added to your network, when there's additional risk analysis, real-time risk analysis, real-time detection of anomalous behaviors specific for IoT devices. That's a key, because as I was mentioning earlier, traditional security tools may struggle with specifically IoT devices, but there's now IoT-specific solutions that have been created to address this growing problem. And the last part here is, I'm a huge, huge proponent of visibility and collaboration and transparency. So building executive dashboards specifically to track IoT risk. Now, some folks wouldn't want to do this just because it means that, hey, all of a sudden my security posture decreased as I'm reporting to the board. But this is very, very important to get that overarching support for an IoT security program. And in summary, IoT devices, amazing benefits. Innovative, availability, really changing the way we do business. But they have a number of different security limitations, which are pretty well discussed. And there's also major privacy implications related to the transmission, process, and storing of unencrypted data, of unencrypted and default credentials being used that can result in privacy breaches, kind of that one hop away. There's the default misconfigurations that they ship with, right? And then lastly, the innovative approaches that we're starting to see a lot of industries, a lot of cities going through. There needs to be a lot of scrutiny around the privacy implications, ethical and legal and so on, that they are looking to, that they can result in. So what can you do? Immediately, collaborate with business units. Review the additional guidance that NIST has, a number of different special publications. Embed privacy and security into various processes for better visibility. Again, comes down to visibility, not only of assets, but from a process perspective. Inventory and prioritize those assets that you'll get through additional collaboration, and then invest in technologies to automate detection of IoT devices and do a real-time risk analysis to make sure that you're staying on top of all the different changes in the environment. And with that, thank you so much for coming and having a listen. Happy to continue the conversation if there's any questions. Okay. Oh, yeah, apologies.
Great presentation, by the way.
Thank you.
My question is, we have not one of those tools that you mentioned earlier.
Yep.
Audit. So we're always looking at the audit universe and going and determining, what is our scope. So one of the pushbacks that we normally get is, this is not my responsibility. Not IoT specifically, but in general.
Yep.
I guess in your experience, I wanted to know, I can totally picture us going to the
Yeah, that's a great question. I think the way and I had a conversation with a C-level just yesterday, he had a really interesting approach. Security, he said, from my perspective, I'm security, and I am responsible for reporting all the risk and the vulnerabilities. The individual owners of the assets are responsible for maintaining them. So if you're looking at specialized environments, security teams will not get involved in patching, or whether it's firmware of IP cameras, OT devices, IoT, and so on. They have their own device maintenance owners, custodians, and so on. They work with the security teams. The security teams say, hey, there's these different ways we can reduce the risk, whether it's we want to segment the network, we want to implement vulnerabilities and what have you. The device maintenance owners then work with the vendors to review those and implement them. So that's kind of the delineation that we've seen, is that security is more interested in the visibility and risk, but in order to actually implement those changes, it's not even the IT department, it's the actual biomedical teams, it's the plant operations teams, it's the owners of the retail technologies and so on. That's kind of how and then once they're done, they close the loop with security, and again, security just kind of reports it up. But that's what we're seeing, much more collaboration and involvement of non-traditional IT or security teams getting involved. Yeah, yeah, exactly. In fact, in some organizations, we're actually seeing those device owners, because there's so much technology involved in their business units, starting to get folded into under the CIO umbrella now. Yes, sir.
So I have a question specifically for healthcare organizations. So you know how we always talk about the needs to the process before you connect an IoT, and for clear this point from security, privacy perspective. Just thinking about COVID and even after COVID, right? I'm sure there's pressures on the operational staff, like nurses and clinicians, like clinic professionals, to get your work done. Which means calling IT and saying, hey, connect this device. How are these healthcare organizations maintaining the balance between making sure that the device connects quickly, but also doing all the threat and risk assessment to make sure it doesn't harm my network?
Yeah, good point. I think healthcare has been notorious for this, and I think vendors are under a lot of pressure, and they're starting to change the way they approach this as well. They're starting to get it really embed security into their process from the get-go, or at least give more visibility in terms of how the device needs to operate. So it's really taking that information, and it's starting to come down to a lot more of segmentation. So when we're looking at healthcare organizations around the world, maybe 3 to 5 years ago, there was a lot more of an educational aspect in terms of IOMT, their risk, what they do, and so on. Now what we're seeing is, whether it's discussions around the world at forums, at RFPs that hit the street, or anything like that, it's all about segmentation. And the Philips of the world, the GEs of the world, I think they've done a phenomenal job, not to discredit vendors continuously. I think they've actually done a pretty good job of now starting to include that information in their documentation. So it's a matter of, even if we can't get to the risk assessment, it's at least locking down the device. Biomed teams tend to also have a test network that they'll plug devices into to configure the devices and so on, because they do need to be reconfigured to point to the appropriate management servers. And then from there on, they understand how the devices are behaving, what they're calling out to, and then the security teams get involved to appropriately lock down the device. So they're getting better at that. The challenge is now the historical devices that are on the network that they need to account for.
And I'm thinking they're probably also defining some sort of SLAs, like service level agreements.
Yep, absolutely.
When something takes these many hours to get connected, then you monitor that case.
Absolutely, and that's one of the guidance HITRUST has now revised, where it's, hey, high-risk vulnerabilities need to be resolved in 14 days. And then they go down to, when you're at low, it's 60 days, but the idea here is that they are setting those hard parameters that in order to stay compliant, you need to meet these. So we're starting to see the healthcare industry as a whole starting to get much more, I don't want to say aggressive, but much more defined in the delivery of and securing of these types of devices.
Thank you.
Yeah, no problem. Cool. All right.